Good morning, John. It is Sunday. Okay, so you might know that I'm currently attending some kind of mishmash of OISE and the University of Toronto. I'm going to get a degree and be able to teach. That is the goal. I don't really know how it works. The end goal is known, though. That's what matters. I'm making this video to try and discuss and shed light on what I think math education is, where I think some errors are, where I think certain things are best addressed. Maybe I'll talk about politics for a little bit, but I don't really know what political people say, but there's a slight divide, so maybe we can touch on that. We're just going to try and see how well I can define math education and where the errors that society make when they try and progress it. I hope that makes sense. It might not. Okay, this backstory could be excessively long, but let me finish. So I did my undergraduate degree in mathematics, and in the very rare occasions that I would go to a party, in undergrad everyone just says, "Oh hey, what do you study?" And then I awkwardly go, "Oh, I study mathematics." And then I pause and wait for them to say, "I'm really bad at math, and I don't really like math." Great, that's what everybody says. So once we got past the lack of originality, I would always act surprised, Macaulay Culkin, and respond with two questions to basically say I disagree with you. My first question is, how do you feel about numbers? And they traditionally say, numbers are all right. I can do numbers, I can understand addition. Numbers seem pretty cool. They're all over the world. So you like numbers. Part two, I say, how do you feel about problem solving? And they say, I'm pretty good at problem solving. And then I go, okay, so mathematics, in my opinion, is just a mix of numbers and problem solving. So what do you have against mathematics? Needless to say, I wasn't making very many friends at parties, wasn't the talk of the town, but I was learning things, and I was studying people and how weird they are. So using my party talk definition, we're going to define mathematics education as the goal of giving students the ability to have numeracy or a skill with numbers, and also the ability to have problem solving. You could argue that something like problem solving would occur in many other disciplines, but mathematics seems to be taught primarily in problem solving, whereas many other disciplines are not, and so it's somewhat fair to assume that mathematics is kind of relied upon as the problem-solving subject. So if we assume that mathematics is some sort of hybrid of teaching students to have good sense with numbers and a good ability to problem solve, then let's think about how classes should actually be going. In the current Ontario political climate, we had a switch in governments. The previous government had a really large push for problem-based learning, or inquiry-based learning, or nonsense, as I like to call it. Basically, you would give a student a problem that was relatively open-ended, and you would just say, how do you want to solve the problem, young person? Without being too mean to that style of education, it is a good thing to do once in a while to say, here are some tools, try and build me a project, try and build me something. That is a great task to be doing. The way that I have been taught math previously, however, has been a lot of apprenticeship, a lot of a teacher saying, here's how I do it, and then giving me similar problems and letting me fill in the gaps that I'm able to fill in given my level of understanding. Another thing that the inquiry-based learning moved away from was number sense and numeracy. I don't know exactly how much it moved away, but there's been a push away from having students learning their multiplication tables, and there's been a subsequent drop in students' ability to do basic multiplication and addition, which is pretty risky territory. I agree that we don't need tiny little robots because we already have tiny little robots in our pockets that are our cell phones that can do most of this for us. But if we have students that aren't confident enough to do single-digit multiplication, then what are they confident doing? I like to make the analogy that in primary school English, You learn how to spell, you learn how to write words, and then later on, given that you can spell and given that you can write words, you then write sentences and write creative things. If you don't know how to use numbers, if you don't know what numbers are, if you don't know how to manipulate numbers, then that really causes an issue in trying to move forward into further aspects of mathematics. It's not a perfect analogy, but I think it holds up. And it also runs parallel to the fact that English is split up into things like spelling and grammar on one side and also creative writing on the other side, where math should be split as numeracy on one side and problem solving on the other. Most of the debates by politicians say that it should be more this, it should be more that. Goldilocks and the Three Bears, I think the porridge should be lukewarm and we should be meeting somewhere in the middle, but that's politics. Making the somewhat massive assumption that everything I've said so far has been true, math is dichotomized into numeracy and problem solving, I would argue that problem solving could then be split up into different parts itself. This old canon of jokes that begins with, an engineer, a physicist, and a mathematician are doing X. And I think an example is a mathematician, a physicist, and an engineer are staying overnight in a hotel. The first night there's a fire in the hotel and the engineer wakes up in the middle of the night, gets a bucket of water and pours it out. The second night there's a fire in the hotel and the physicist wakes up. He does some calculations, determines the minimum amount of water he would need to put out the fire. He fills up the bucket to that much and he puts out the fire. Then on the third night, there's a fire. The mathematician wakes up. He addresses the fire, does some calculations, and determines that he can, in fact, put out the fire, and he goes back to sleep. And they all die. The joke is that when a mathematician addresses a problem, they rarely actually solve the problem. They just determine that it can be solved. Majority of high school mathematics is more high school engineering or more high school physics in that we're giving you applications and you're solving them. Things like logarithms and trigonometry are used to solve real-life applications. And I think that's beautiful. I think that's great, and I think that is something that students need to continue to do to flourish in their education. However, there is this whole stream of problem solving that is waking up in the middle of the night just to determine whether or not there is an answer and how do you find that answer that isn't really being addressed in high school math education. An important thing in mathematics is a proof. Without a proof, we have no definitive proof that what we are doing is continuously verifiable. The case of the fire in the hotel is a little bit wishy-washy because the proof would essentially be that we know that water puts out fire, therefore X amount of water will guarantee that the fire will go out for suitable X. Maybe that's the proof that the mathematician came up with. Who knows? A lot of the applications and theories that we show in high school aren't always rigorously proved or rigorously supported. Rigorously proving theorems isn't the worst thing in the world. In the historical timeline of mathematics, most of it was without rigorous proof. A lot of the things that mathematicians were assuming, though they are somewhat obviously true and could be taken as given, hadn't rigorously been shown so. Given this historical case, it does make sense to give students a bit of leeway and not having to show everything that they do at a rigorous level, but it's still fair to say that there should be some level of rigor and advancement shown to students. Finally hit what I've been wanting to talk about for this video, and the subject that I wanted to get to is the area and the field in math education that are math contests. The idea of a math contest is traditionally you take your highest performing students, you stick them in the cafeteria, you stick them in the gym for about 2 hours, you throw some really hard math problems at them, you see how far they can get, you see how many they can get right, and you crush some spirits, but it's all for the fun of mathematics. The math contest is one of the few places in high school education where students get to interact with rigorous proofs. Most of the questions on math contests ask students to prove various facts, various lemmas from important theorems of history, and try and guide them further in their math education. As a future math educator, I look forward to my interaction with math contests and the students that write them. I think they're an amazing opportunity to provide students with the enrichment that they wouldn't normally get at a high school level and is more reserved for the university setting. A question I would like to explore is how can questions that find themselves on math contests be better brought in to a regular setting, because a lot of them are quite fun. And that might be me being really nerdy and thinking that they're fun, but they're generally intricate and based off of really beautiful patterns that all students would benefit from exploring. There have been a few teachers that defined what math contests test you on as the hidden curriculum. It's hidden curriculum in that they never explicitly state what it's going to be on a math contest, but you can somewhat predict that it's going to fall in the categories of geometry, or algebra, or number theory, or combinatorics, or graph theory, and all of these things make their way onto math contests. These are all beautiful fields of mathematics that are somewhat steered clear of in the high school curriculum. My question is, would this hidden curriculum be better placed in a general high school setting so that every student could have the chance to appreciate math as something that isn't just brute force and that instead has beautiful intricacies for them to appreciate? I defined what mathematics is to me. I broke it down into a few categories. I said that some of these categories are missing in high school education, and I want to know how can we bring them back, if they are even really needed. Maybe I would like to say that the conclusion of my video should be that students instead are afraid of math, that they're afraid of engineers and they're afraid of physicists, and mathematicians are actually quite beautiful. But I think the point is slightly more subtle than that. I'm trying to say that there are a lot of intricacies involved in mathematics that you can't cover in a high school setting. You're required to uncover ideas that took mathematicians hundreds and hundreds of years to discover, and you expect high school students to work through them in a matter of 4 months, while they themselves are at most 17 years old. Maybe you shouldn't have to write advanced proofs in your high school career. But where do you start writing them, and how can you best introduce that to a young mind? Anyway, John, that's all I've got for today. I look forward to seeing you on Tuesday. Thank you.